Hello everyone. In the earlier video, I asked you a question. Then where do you think you are going to implement lean thinking in a supply chain? The answer is that you should implement lean thinking in the entire supply chain, from supplier to the retailers. So lean thinking should be implemented in the entire supply chain if you need the maximum benefit of lean thinking. Now let's have a look at lean operations and agility. Now what is lean operation? So lean operations is all about eliminating the waste or trying to minimize the waste or wasteful activities, the 8 type of waste we have learned in the last video. To make the operation much faster, quicker, and to produce high quality product and services, and try to minimize the cost of production and achieving the high volume production in the minimum cost. That is what the lean operations is. But if you think about lean in practice, lean product design can have standard parts. For example, the same parts is going to fit in different type of products. As an example, you can have one diesel engine, let's say 2-liter diesel engine. You can use that diesel engine in different models of a car. Same thing, all the pen drives, USBs, the cables we use that can fit from one computer to another computer. The phone chargers you are using, the same charger can be used in other phone as well. So standard parts, you can use the same parts for different purposes. Modular design, for example, designing a window or designing a wall panel or tiles that can be used for different purposes from one place to another place, from one home to another home. Modular design, lean layout, manufacturing cells, and group technology. In that, we can have several different departments or maybe several different workstations at one place to make sure that there is limited motion, there is limited movement, there is limited transportation, and limited or less cost to the entire operation. Just-in-time production where we only produce based on the demand when it is actually needed. So just-in-time is all about providing the material component or the finished product when it is actually demanded, either by the workstation in the assembly line or by our customers. Lean production schedule, where we use Kanban production control system, which is the pull system, pulling the product in the assembly line, and that is based on the demand from workstation B to A, workstation C to B. And lean supply chains, which is the entire network. As we have already talked about, that if we have to implement lean, we have to implement in the entire supply chain. So lean supply chain, the supplier network, we can use lean to create flow in the entire supply chains. So let's have a look at those one by one. The first one is lean product design. So in lean product design, we have talked about standard part and modular design. So standard parts can be used from one type of manufacturing to other type of manufacturing, from one product to another product. We can use the same parts, like the engines again. We can use the same engine to build different models of a car. We can use the same components to build different type of computers. So same parts being used from one type of model to another type of model. In the modular design, we can use same type of product to build something else. So if we can replace windows from one type of window to another type of window, that can be done as well. The idea is to build the product with easily replaceable parts. So you got one house And in that house, if you just need to change the window, you can easily change the window. So that is a modular window. Or sometime if you need to change the SD card in your mobile phone, that is a standard SD card. So you can just, when it is full, you can just switch it with a new SD card, which have more memory for you. So you can use these type of things like standard parts and modular design. At the same time, in standard parts, you can have standardized tools as well. So the same tools can be used by workstation 1 and workstation 2. Same tools can be used by the people who are manufacturing cars. Same tools can be used by the people who are manufacturing motorcycles. So all these tools, the standard tool, can be used by different type of manufacturing and assembly. So this is the lean product design, where we have standard parts and modular design. That will give us opportunity to reduce the cost of buying those tools, to reduce the cost of just changing one piece of something. For example, if your hard drive is corrupted, you can just go and buy a new hard drive and change it in your computer. You don't have to change the whole computer. So that is the idea, that with the minimum cost, the repair can be done very easily. And with the minimum cost, you don't need to buy a lot of tools. The same tool can be used by workstation A and workstation B. Again, you don't have to manufacture different type of engines, maybe 1.6, 1.8, 1.9, or like 2 liter or 3 liter or whatever. You can use the same engine in different type of cars. So this is the idea. So when we are manufacturing the same engine or same tools for different workstations, the cost of switching from one assembly line to another assembly line is very, very low. So that is why the lean product design, we need to have standard product and the modular design. Because standard product to save the cost of manufacturing, modular design to save the cost of repair and maintenance. So that is the idea in lean product design. Now, what is the idea of just-in-time? Now, just-in-time production is when we are producing something, there should be a demand for it. So that means we are only producing what is needed, when is needed, nothing more than that. So if we have demand for 100 products, we are only producing 100 products. Now, when we only produce what is needed and we are not producing to stock or make to stock, that saves us a lot of space to keep the inventory. That saves us a lot of cost as well to manufacture or to produce more product than demand, and keeping those products and waiting for selling those products when the demand is there. So we are moving towards made to order, not make to stock. It is normally a repetitive process. We keep repeating just in time. So for example, today we got demand for 10 cars, we only produce 10 cars, not 11. If tomorrow we are going to have demand for 15 cars, we're only going to produce 15 cars. We are not thinking about tomorrow. We're only producing what is needed today. The lot size are 1. So for example, today 10 cars, that is one lot size. The tomorrow 15 cars, that is another lot size, that is 1. And it is possible that in the morning, the lot size 1 is one specification of the car, one particular model of the car. In the afternoon is a different model of the car. But in evening, there is a third model of car. So we can produce in that way as well. But in that case, we need to have shipment or deliveries more number of times. So we have to think about the trade-off between the number of deliveries and the production, how much we can keep in inventory. Do we have to keep, like for 10 cars, do we need 10 engines in stock? Or if we are producing 50 cars in a day, out of 50, 25 is Model A and 25 is Model B. Should we order 50 engines in one go for the whole day, or should we order 50 engines to be delivered by morning and 50 engines to be delivered in afternoon, because we only got capacity to keep 50 engines in stock. So that is the way we need to think about in just in time production. So when we actually have demand, let's suppose we predicted that there will be demand for 25 cars model A, so we need 25 engines for model A, or let's say 25 petrol engines and 25 diesel engines in the afternoon. Now if you predicted that, but we sometimes we can't just go based on the prediction. We sometimes go on the actual demand. If the actual demand is 20 cars, what will we do with those remaining 5 engine if we order that on that day? So that 5 engine will be lying there until unless we got demand for another 5 cars, or either petrol or diesel. So we need to think about that. Okay, we are not keeping those 5 engine in stock. We are just going to order 20. We don't want any inventory, because keeping inventory is a cost as well. Let's look at a bit more in just in time. So for example, in the traditional system, we got long production runs. Long production runs means that we started manufacturing something and we are manufacturing the same product 24/7, 365 days, which is the continuous or mass production. So we are not doing it nowadays, because there are a lot of variation in the products. If we just talk about one particular car, that can have several different models, and each model can have several different specifications: specification 1, specification 2, 3 and 4 and 5. So we are not manufacturing those cars until unless we got the demand. Now another example, if the firm has 3 product versions, for example A, B and C, in the traditional system, or a long run of the version, we are covering 2 or 3 days or more when the long run of version B. So we are manufacturing one product for 2 or 3 days, then the second product B, which is we are producing for 2 or 3 days, and the third one 2 or 3 days. So what will happen in that case? The lead time for delivering product B will be extended 3 days for your customer. So and same thing happened with the product C as well. So what can we do? If we got demand for product A 50 pieces on day 1, and at the same time we have demand for product B again 50 pieces, so we can produce product A and product B on the same day. So that is the just-in-time production system. Now another example, let's suppose a bakery does a production run of 14 batches of cookies every morning, and what happen every time they have to switch from one batch to another batch, there is additional cost of that switching time, the changeover time. When the changeover, the machine, maybe they are cleaning the machine and they are putting different parts or different type of dyes or whatever, and they're doing something in the machines. So when they switch over, the changeover time from one type of batch or one type of production to another type of production, that is a waste of time. Now the drawback of having that is, when we switch from product A to product B, the changeover time could be, let's suppose that if the changeover time is half an hour, so that half an hour the machines are not producing anything, because that is the changeover time. That is a waste for us. More number of changeover time, more the wastage will be. So we need to think in that way as well, that okay, should we have 2 different assembly lines for product A and product B, or should we have one assembly line, or and we can have changeover? But also we need to think about how can we reduce that changeover time from half an hour to maybe, like, let's say 5 minutes or 2 minutes or 3 minutes, so we can save that time, and within that time we can produce more. Now related to the same example, process design, where we got small lot sizes. In the small lot sizes, the small lot approach for in this example, so for example product E, we need to manufacture 3 units. Product B, we need to manufacture 8 units, 7 units. Product C, we need to manufacture only 2 units. So this is the changeover time. this is another changeover time. This is third changeover time. The fourth, fifth, sixth, seventh, 8, 9, 10, 11, 12 changeover time in the entire day. So in that changeover time, during that changeover time, we are not producing anything. So that could be a problem. That will be a problem because we are not producing anything. We're not utilizing the resources. The machines are idle. The people are idle as well. So we are not producing during that time. But at the same time, we look at the large lot approach where we are producing large lots. So for example, product A, we are producing 20, then product B, we are producing 30, then product C, we are producing 15. Now over here, we only got 3 or 4 changeover time, 1, 2, 3, and 4. So 3 or 4 changeover times. So in that 3 or 4 changeover times, we are manufacturing more. Our changeover time, the wastage is less, but we are manufacturing, maybe we have to store those items. At the same time, we have to keep that inventory before we sell it to our customer. But over here, whatever the demand is, if the demand is for 3, we are only producing 3. If the demand is for 7, we are only producing 7. The demand is for 2, we are only producing 2. Now, there are always pros and cons in both the manufacturing system. But mainly when we talk about lean production, lean is mainly known as large batch sizes, large lot sizes. But nowadays the production is moving from large to small batch sizes while trying to reduce that changeover time, that time we are not utilizing our capacity, or we are not utilizing the full capacity of the machines and the people. So we also, again, it depends on, for example, depends on product to product, depends on component to component, which component we should produce in large lot sizes and which component we should produce in small lot sizes. So as an example, BMW is manufacturing X5 model. In X5 model, let's suppose the engine is 2 liter, and for all the X5 models, the engine will be 2 liter. So what they can do, and they know they are going to produce at least 1,000 cars within this month. So they need 1,000 engines. So for that 1,000 engines, they can go for a large lot approach, that okay, they need to manufacture those 1,000 engines within a month's time, and every day they are going to produce like 20 to 30 or 40 engines every day. So that could be one of the possibility in the large lots. But in the other parts, in BMW, for example, they have different variation in the color of BMW. So they might sell 3 black, 5 white, 2 red, or 3 green, or different colors. So in that case, they are only producing 3 white based on the demand, based on the actual demand when customer asks for a particular color. So they are producing 7 white, they are producing 2 green or red color based on the demand only. So that is kind of, we also call it postponement. We are manufacturing the engines in large lots, we are manufacturing the chassis in the large lot, but when it comes to color and customization based on the customer requirement, we are talking about the small lot sizes. We are going to learn about this in bit more details in the next video. Now, the last one is lean production Kanban system. So in Kanban system is basically has the color coding, or maybe color cards, or the visual cues, or having the colored containers, or the color lighting system like the traffic light. So it is all about giving signal that I'm okay, I'm running out of the inventory, I'm completing my task, whatever task I'm doing. Now I'm good to receive more inventory from you, because after within, maybe let's say within half an hour time or within 10 minutes time, we will be running out of the inventory and we need more inventory. And that is where the just in time comes in. So for example, you are workstation 1 is manufacturing some material for workstation 2. Workstation 2 already have the inventory in process. So when they're running out with that inventory, they give a green signal to workstation A, and workstation A will send the more material to workstation B. So that is Kanban. It is like a pull demand. I need more, so I'm pulling the products from workstation A, while showing them the green light or leaving the container empty. So when the workstation see the container is empty, they go and put more inventory based on whatever they schedule, maybe 10 or 20 or 50. So instead of keeping a lot of inventory at that stage, they just give small quantities of the inventory, so we don't have to keep a large inventory over there. Sometimes we use our vendors, which is the vendor managed inventory, our vendors to send the inventory after every interval. So interval can be decided. It could be 1 hour, it could be 2 hours, it could be 3 hours, based on the capacity of workstation B. If the capacity of workstation B is 100 unit per hour, so the vendors will refill the inventory with 100 units per hour just in time when it's required. So vendor will see a signal that yes, more inventory is needed now, and they will only go there at the time when it's actually needed. So just in time within the assembly line and within the production system. Now in the next video, we will talk about how lean is all about reducing the waste and continuous flow, adding value and continuous improvement. When we reduce waste through lean thinking or implementing lean tools and techniques in our production system, it will reduce the cost of the production as well. And it will make the process faster, the manufacturing process faster. But at the same time, now because of the mass personalization, because of the mass customization, for example, again, one BMW X5 can have several different variations. Now because of the variation, the demand changes. Some customer want black, some customer want red, some want white or some other color. Based on that demand, we need to be flexible as well. So lean is making it faster, but we need to be flexible as well. And that is where agility comes in. We need to be flexible, that we can change from one type of production to another type of production as quickly as possible. But we need to be agile. We need to be much more flexible and responsive to the demand. So that is where agility comes in. In the next session, in the next video, we will talk about being agile and agility in our production system and in our supply chains. Till then, thank you very much.